What we do in life and who we become is defined by what we create along the way. Here at Design FYP, students are beginning their creative life journeys. Each student has created something unique, something which tells about who they are and where they are going. My name is Matt Collins and I am one of the exhibitors from Design FYP here today, and I have begun my journey towards becoming a creative and professional engineer. I'm standing here on the steps of the former Franciscan Church in Limerick, where the Design FYP exhibition is being hosted. This exhibition features a selection of recent design projects from 4 design disciplines in UL. These disciplines are architecture, product design, civil engineering and digital and interactive media. Follow me now through these doors and let me tell you about my part in this exhibition and my journey so far. While in London on work placement, I encountered many unique structures while on my way to work, such as the Millennium Dome and the Velodrome in the Olympic Park. I was drawn in by their free-flowing form and was intrigued to find out more. This, coupled with a long-term interest in timber, led me to uncover and study the unique structures that are gridshells. A shell structure is made up of a rigid material which can adequately transfer loads through in-plane forces. It also has a very small thickness in relation to its other dimensions. A good example of a shell structure is an egg, which is strong but not infinitely strong. A grid is a framework made up of crisscrossed elements or parallel line-like elements. A grid shell then takes this grid and pushes or pulls it into a shell-like shape. These types of structures lead to unique and free designs. Some examples of more complex grid shells are the multi-hall in Mannheim, Germany, the wheel and downline grid shell in Sussex, England, and the Savile Garden grid shell in Windsor, England. I wanted to find out more on how grid shells worked and how they're designed, so for this reason I based my final year project on investigation into the analysis and design of grid shells. From this research, the complexities around the analysis of grid shells were identified. The main complexities identified were form finding, material selection and joint behaviour. The architect develops a preliminary shape. From this starting point, I then create precise surface geometry using sections of spheres. I then develop a grid pattern on this surface. Each node represents a crossover point of lats on the grid shell. Once a shape has been selected, it is analysed to ensure there is no overstress. Stresses in a grid shell occur both from curving the grid and from imposed loads such as wind and snow. If it was overstressed, the grid shell geometry would have to be altered or a more suitable material selected. The structural analysis of a grid shell is complex and not suited to Halden calculations. Therefore, a proprietary software package was used in the form of Abacus finite element analysis software to determine the response of the structure to applied loads. A systematic approach was adopted in using this software by means of creating, analysing and checking gradually more complex structural models until the full complexity of grid shells have been achieved. This, however, needs to be validated. Validation was done by developing physical lab models of the exact same sequence of structures with the same loads applied to verify the computer model. The physical lab model of the grid shell is what you see here. It is made up of elements which were initially straight and joined at the nodes using a nodal joint which eliminated torsion. This grid was then formed to create the grid shell by forcing the end nodes into predetermined boundary locations. This now is a grid shell. However, the grid shell in this state is not a stable one. Therefore, bracing system in the form of tension cables was installed to make the structure more stiff and stable. So far, I have succeeded in predicting very approximately the behaviour of one such complex grid shell. I have delved into this fascinating field over 7 months. I would love an opportunity to further develop my expertise, fine-tune the analysis and design, improve my understanding of material and joint behaviour, and realise more of these elegant and sustainable structures.